Okay, hello. Um, Welcome to my session where I talk about, or I will be talking about genetic algorithms and how to evolve solutions. But I like to call solutions entities instead because I would like to think of them as living beings. And because if something has a gene or genome or DNA, that indicates that it is alive, or that these things are alive. So it's a life form, so I call them entities. I find that solutions or just things are a bit, calling them solutions or things or any other conventional terms are a bit derogatory. So entities, I call them. That's that. And in future sessions, I'll be talking about how to evolve entities and what to do when it comes to evolving them, finding out the right parameters or hyperparameters, finding out the right methods and techniques, and what is good or bad practice, and what actually is the definition of good or bad, or better or best, for that matter, which would also depend on what the problem that I am trying to solve is. And because in the real world things change, and what used to be a problem might not be a problem tomorrow or next week or next month, next something, next period. So yeah, that's that. I'm sure I'll be ranting about this more as there are more sessions to come, and I'll be just ranting kind of as a memo for myself. Well, mostly for myself. So this is a lot like a video log. So here we go. So first off, I'm just going to import stuff, and as I import stuff, there aren't many things to import, and this is mainly because I'm trying to build everything from scratch as much as possible. So I don't want to be importing already built libraries or modules or packages, whatever. So trying to stick to the most basic Python functionalities as possible. So I'm only importing random, and from itertools I'm importing compress, combinations, permutations, and product. And in this notebook, what I will be doing is I have this problem, and I will be generating all possible solutions. And then when that is done, I will apply the constraint to find out what the best possible solution slash entity is. Right now it's calling it a solution is fine because every solution or none of these solutions are actually alive yet. So, but anyway, back to the point. Generating all the possible entities so that I will be able to know when the constraint factor is applied, just spot out the best possible entity. That's it, given all the other variables and conditions. So I ran that cell, import stuff. Next cell, I don't really need it, but so I just commented everything out. Just gonna run it anyway. Doesn't do anything. And this is the problem. I have a list of items, 20 items, which are MacBook, mouse, keyboard, vape, juice, AirPods, wallet, pen, perfume, bottle opener, sunglasses, headphones, cigar, lighter, phone, glasses, book, notebook, coffee, folder. And all of these values, all of these items have an intrinsic value to me as this cell stored in the Python list called values list. And they're not actually in order, but they're kind of in order. And all of these utility values, or just values, are very subjective to for me and to me, because I judge them. I put in these numbers, just integers, and based on how much I feel that they are important to me in my everyday life. So as you see, MacBook, very important. Mouse, less important, because MacBook has the mouse pad or trackpad. Keyboard, the laptop MacBook already has a keyboard, so that's okay. Vape is important. Well, used to be important. Vape juice. This is what I mean by vape juice. Well, juice is, vape juice is what I mean by juice. If I were to rephrase that. And then AirPods to listen to my laptop or my phone. So it's kind of important. My wallet is very important, as important as my MacBook. Pen, a pen is important. Perfume, not so important. Well, pen is not that important either. Bottle opener, it's not that important. Sunglasses, not important right now because it's winter, and when this notebook was also being created, it was also winter, so not that important. And headphones, very, very important, but I'm not carrying that around. Anyway, cigar, not that important. Lighter, not that important. Phone, very important. Glasses, not so much. I don't need glasses. I just wear them as a fashion statement. A book, I don't like reading. Notebook, quite important if I were to make notes or just plan things. Coffee is very important. A folder for where I keep my notes is also very important. So that's that. It's very subjective. This list itself is very subjective. And also so is the constraints list. And in this case, a constraint is the weight of the item in this very problem set. So a MacBook has a constraint value, or think of it as a weight value just for this case for now, 1500, which is like in grams. So it's like 1.5 kilos, maybe not, roughly. It's not exact. These are not like exact metrics. A mouse, 200 grams. Keyboard, vape, yada yada yada, on and on, blah blah blah. So here they are: the items list, the values list, and the constraints list. And next up are the custom functions. And what I mean by these custom functions, is that there are two main functions in this notebook. The first custom function is the fitcal, or the fitness calculator. What this does is calculate the calculate the amount of utility values that is selected and just add them up. Well, calculate the total utility value of the items, total sum value of the selected let me just take that slow. Let me rephrase that. Calculate the total summed utility values of the selected items. Yes, that's how I should say it. And return the value. And next up is the constraint calculator. Constraint calculator. This is the same thing, except that in this case it calculates the total sum of the constraint values in the list of items. So for those of you, or for those people who are not familiar, I'm trying to come up with the best list, Python list of zeros and ones, which and a list that is 20 inputs long of zeros and ones, where a zero means that the item in the same place means that it is not in the total package or in my backpack, because this is usually called a backpacker's problem. And if the value is 1, it means that the corresponding item is in the backpack. So an example list could look like this: 1 1 0 1 1 0 0 0 1 0 0. So that would be like 1 for MacBook, 1 for mouse, so these are in. 0 for keyboard is not in. 1 for vape, it is in. So that's it. So custom functions have been made and run. And now, since I'm not going to be actually doing any kind of genetically algorithmic evolutioning, instead I am going to be generating all possible combinations of ones and zeros that are 20 places long. So that's 2 to the power of 10, which is 2 to the power of 10. 2 to the power of 20, sorry. So that's 1,048,576 possible combinations or products. How do you, okay. So, and I'm just going to save all of it in a list. And here we go. I have an empty list called all genes or all genomes, or just all solutions, depends on how I feel like naming them. I initiate or instantiate, is that the right word? I create a generator using the one of the packages or one of the functions that I imported. I give it the choice of either, I give it 2 choices to choose from, 0 or 1, and repeat that 20 times. So I make that, and now that I have a generator, I have to iterate through the generator. So do that, and I'm going to run it. I'm actually very, very, very afraid, because I don't know how long this will take. But yeah, because I'm working on Google Collaboratory environment, the very basic, so it's not going to be that fast. And from my previous stream sessions, I have learned that it is like 3 to 4 times slower than my MacBook that I bought this time last year. So I'll just run it. Yeah, see, it worked. So that was quick. So now what I'm going to do now is iterate through the list that is all genes, where all the possible combinations are stored in as lists in a list, and calculate the utility value or the fitness value for that solution or entity in the future, and store it in a dictionary called util entities dictionary. And also I'm going to calculate the summed constraint value of an entity and save that in the constraint entities dictionary. Yeah. And if one util value is already present in the dictionary, in any one of the dictionaries, the additional list that has the same utility value or the constraint value will be just added on to the dictionary under the same key as an element of the pre-existing list. So these dictionaries will have the keys, which are the values, utility values, or the summed utility values, or the summed constraint values, and the items of this dictionary will be a list of entities that correspond to the summed utility value or the summed constraint value. I just hope this doesn't take long. Only took 5 seconds. That's not supposed to happen. Please. Why did I just get one? Because I ran the script before, the whole notebook before. I'm not. The values are not supposed to change. What happened? Well, this is embarrassing, but I mean, this was the whole point of the recording session, so I should just keep recording. As I go through. I have no idea why it changed. Hello? That was okay. Huh. I have no idea why it was 161. Maybe I'll find out why as I go on. So the two dictionaries containing all the summed utility values and the summed constraints values and their corresponding entities have been created and made. So I'm going to sort them in descending order, which is what I'm going to do now as I run this cell. And when I run it, I am going to get something like this. Let's hope it doesn't change. I mean, the whole thing is going to have a million lists. More than a million lists. Maybe I should keep that for now. Maybe I shouldn't have pressed enter. It's gonna take a while. I feel like an idiot. Thank God. Really? Like, see, scrolling all the way up. There we go, I see it. Yeah, people have warned me not to do this, but I do it anyway again and again and again because I'm so dumb. There we go. So the best one being 800, but it is the best because in terms of utility values, summed utility values, this one is the best because it just contains everything, all 20 items. So of course this is going to be the max. Yeah. And all the way down to probably nothing. So 800, well, no. But I must add that all the utility values and the constraint values were given kind of very arbitrarily and randomly. So yeah, so they're not even accurate or anything. And next up is the constraints entities dictionary. And I'm waiting. Is this also going to take 23 seconds? I think 23 seconds has already passed. Maybe it's going to be 40 seconds. I really should stop printing everything. I mean, it is a million things. Is there a way to get rid of this? Yeah, let's clear the output. Please work, please. Yep. So while this is going on, I'll just briefly talk about what is going to come next. So if we have, since I have all the possible solutions, entities, all I have to do is apply a threshold or a constraint, global constraint or whatever, to so that entities with too high a constraint value don't make it, or rather, yeah, so that they don't make it, which is kind of obvious, because if you were just supposing that, if you were trying to pack everything, pack things, not everything, pack things into a backpack, and of course the more the better if you can carry it, but no matter how strong you are, more weight is more weight, so more constraint is more constraint. It doesn't matter whether you can afford it or not. Something good is good, something bad is bad. More weight is more weight. Of course, it is going to have its own, benefits to it, but still, the fact that it comes at a cost does not change. And also, here again, the heaviest one being this, where the list just has everything in it, so which is obvious because we just packed everything. And this all the way down to probably 0. I'm just going to clear the output again so that it doesn't slow down. And now I have again arbitrarily set the constraint threshold at 4,000. So I don't want my backpack to be more than 4 kilos without, excluding the backpack. My backpack can only hold 3,999.999999999 forever, never-ending nines and grams. So less than 4,000. That's what I want. So to do that, I'm going to create an empty dictionary again. That the name there, selected dicts, shouldn't be selected dicts, but and then what I'm going to do is iterate through all the keys in the constraints entities dictionary, because keys are the summed weights, and exclude keys that are above 4,000. I did that? Yep. And then the selected keys, and keys, selected dates. Yeah, and put it back into the new selected dictionary or whatever, into the empty dictionary. So I did that, and the length of the new dictionary should be, I mean, it says 793, 793, but I should really stop printing everything. Because it slows down everything. 793 it is. I hope it's I don't know why. So moving on, and then I am going to calculate the summed utility values of the entities that had summed constraint values less than 4,000. One got added, I don't know why. And what I'm going to do is calculate all of the calculate the summed utility values for all of the selected entities, and reorder them in descending order from highest to lowest. My laptop has actually kind of frozen from all the displaying. I really shouldn't do that. So still waiting. Here we go. So, well, this bit is as expected, because I know, well, I knew and I know that the best possible solution is this list, this genome, and it wasn't intended. It just happened to be. It just happened that there is only one entity with the highest summed utility value, with a summed constraint value less than 4,000. So now we know. I shouldn't be burping into the microphone, but anyway. Now I know that, let's just say that now I know that the best one is this one, 710. And I have managed to do this in 28 minutes, but if I were to do it quickly, more quickly, without recording it and with all the code just intact and in place, it would be a lot quicker. But so that's just 710, and oh yeah, and 705, 700, 7 entities at 700, 6 entities at 705, 695 has 1, 2, 3, 4, 5, 10, 14 entities, and on and on and on and on. So 710 is what we will be aiming for. So now that we know that 710 is the best out of all the 1 million something entities, possible entities, my goal in the next sessions to come would be to devise a way to generate entities as close to 710 as possible without taking too much time. Of course, right now, doing this just by brute forcing and brute force iterating through all the million possible entities is possible and doable, and probably saves a lot of headache and a lot of headaches and ideas and hassle, whatever, a lot of coding as well. But the reason we do this, the reason I do this, actually, let me rephrase that. The reason people have come up with this method or technique called genetic algorithms is that if the problem space is too big, or if the list of genomes is too long, like 30, all we get, no, we would be dealing with a billion possible combinations. If it's 40, 1 trillion, I think. Yeah, and on and on and on and on. So the number of possible entities just skyrocket exponentially. So it from a certain point, after a certain point, in terms of number of genes or number of zeros or ones in a list, it's just not feasible. It's just not advisable that you do this by brute force iterating or brute force computing. It'll take years and years and tens of years and well, decades, that's what you call them. Years, decades, or even millions of years. It's just not wise. But right now I'll just be working with 20 items. 20 items and 20 elements in the entire list. Of course, limiting the number of items to pack is also like kind of worth looking into. But then again, it limits the entire space so much that you can just brute force it. Because all you have to do, if you were to take 2 items only out of the 20 items, you just have to calculate the number of combinations possible, which is like 20 times 19 divided up by 2, so that's 380 divided by 2, 190 combinations, 190 possible possibilities, cases. And so that's not so hard. You just need to calculate the constraint values and the utility values, summed constraint values and the summed utility values 190 times each. So 380 times again. And voila, just pick the best one. Yeah. But not setting how many items you can choose from n number of items is worth looking into. Because then, if there are more than 20, 30, 100 items, genetic algorithms start being very worth the time and effort. And I think I'll just end here for this session. Just a reminder, 710 is what I'm looking for. Thank you for watching. Goodbye.